Hey, 8th graders, today's lesson is 1.3 thermal energy. This is our first Amplify lesson for this thermal energy unit. Your learning targets for today: I can describe the motion of molecules in samples of different temperature. So we're going to start looking at different temperature objects, and then what do the molecules inside of those different temperature objects look like. Okay, so that's going to be our main focus for today. Okay, since we are starting a new unit, you guys need to add to your OneNote. So new unit means new section. So you guys are going to click and add a new section, title that thermal energy. And then to that thermal energy section, you guys want 2 total pages. There should already be one there for you. So add a new page and then title both of those pages vocab and key concepts. Okay, so it should look a little something like this. We have new section right here, thermal energy, and then 2 new pages, vocab and key concepts. Okay, all right, and then to the key concepts page, you guys are going to add your unit questions. So our whole unit is going to be investigating temperature, what temperature is, and how things can change temperature, what that looks like between different objects and different molecules. And then 3 key concepts to add today. Objects are made up of molecules, so technically matter is made up of atoms or molecules, or other types of atom groups. Okay, so let's take a look and pause really quick to your guys's vocab. You guys should add the word molecule. Molecule is a group of atoms joined together in a particular way. Remember that an atom is our smallest building block of all matter. Okay, we can divide it, but it's not stable if we divide it, so we'll say it's a stable building block. Okay, let's take a look, for instance, at water. Water is H2O. So if we look at this little molecule right here, we've got 1 oxygen atom and 2 hydrogen atoms, and those come together to form 1 water molecule. So molecule is the key word there. So that'll go in your vocab. Okay, key concept 2. When an object gets hotter, its molecules are moving faster and have more kinetic energy. So we'll take a look at what the molecules in an object look like today. And key concept 3, when an object gets colder, its molecules are moving slower and have less kinetic energy. So how are those molecules moving, and what does their kinetic energy look like? Okay, moving on to your bell ringer for today. There's 4 statements you guys are going to read through, and then you guys will circle with your draw tool whether you agree or disagree. Okay, first statement: temperature is a measure of how hot or cold something is. So do you agree or disagree? When something heats up, it moves faster, and when something cools down, it moves slower. Agree or disagree? When something heats up, new energy is created, and when something cools down, energy is destroyed. Agree or disagree? And then hotter objects have more energy than colder objects. Agree or disagree? Okay, take a second, pause this video if you guys need, go back, do your part 1 notebook, and then do your bell ringer, and when you're ready, we'll move on to the next part. Okay, moment you've all been waiting for is the awesome Amplify video that you guys get. This one, we're going to be kind of looking a little bit about heating systems for school. So what are different options to heat a large building, and how might those look? So that's going to be your guys' investigation throughout this whole unit. Okay, so take a second, pause this video, watch this short 2-minute video. It looks a little bit something like this. Okay, and when you're done, come on back and we'll move on to the sim. All right, so this is the sim for you guys. First thing you're going to want to do is just open the sim up and take a couple minutes to just explore how to use the sim. So launch the thermal energy sim, explore the sim on your own, investigate how the simulation works and what items or variables you can change. Discuss the following questions, or think about the following questions since you're working at home. What are some things you guys can do in the run feature, and what are some things you can do in the analyze feature? Okay, so go take about 2-3 minutes, explore the sim, figure out how to work it, figure out all the ins and outs and the data you can collect. You can pause this video and then go right into your sim. Go ahead. Okay, so the other day we did a little race in class. If you guys were here for that, you guys were a part of it. If you guys are not here, there was a video that you guys can go back and watch. But basically what we did is we had 3 beakers of water. And in those different beakers of water, we had hot water, room temperature water, and ice cold water. Okay, we did a little race where we dropped food coloring in each of those 3 beakers at the same time and saw which one became uniform in color first. So you guys all kind of got to vote and figure out which one was going to disperse the food coloring first. Okay, what we found out is that the hot one is going to disperse that food coloring faster, so it's uniform in color, versus the cold one was really slow about dispersing that food coloring. You can almost see where it dropped in and everything. Okay, so 2 samples of water, 1 hot, 1 cold. Food coloring is added to both. The food coloring spreads more quickly in the hot water and the cold water. So in the sim, you guys are going to make that demonstration kind of come to life in the sim. So open up the simulation. You guys are going to add 2 same size samples, small, medium, large. That's your choice. You choose, but they got to be both the same size. Make 1 sample hot, 1 sample cold. Again, you guys can kind of choose the temperature of what that looks like. And then observe the differences in the 2 samples. Okay? You will answer these questions. What do you notice about the movement of the molecules of the 2 samples? So again, take a look at what those molecules are doing for each of those samples. And then explain what you discovered from the sim about why food coloring spreads faster in warmer water. So that warmer cup that we looked at, why did the blue coloring or the red coloring in class disperse faster than the blue coloring in the cold water? Okay, so answer that question using what you guys saw in the sim. Okay, when you guys are done with that, come on back to this video and we'll move on to our reflection. Okay. Reflecting back on what you guys saw, we have a little kind of diagram for you guys to look at. So look at the 4 images and the key. Answer the reflection question and explain your response. So we've got a key right here that shows us molecule speed. We've got low molecule speed. High molecule speed is going to be that yellow color. So if they're moving faster, low is going to be more of a blackish gray. Okay, we have 4 different samples. We have sample A. Here's hot water, cold water. Sample B, hot water, cold water. Sample C, hot water, cold water. And sample D, same, hot water and cold water. Here's the question you guys need to answer on slide 9. Which image shows the difference between the speed of molecules in hot and cold water? Basically, one of those samples is correct between A, B, C, or D. Which one shows the correct speed? You guys would circle either A, B, C, or D, and then explain your choice right there. Okay? All right, I'm going to go ahead and explain the next part, and then I'll let you guys kind of work for the rest of the day. So last little part is an article to read called Absolute Zero. So you guys may have heard of Absolute Zero before. Article looks like this, so open up that link. You guys need to read through the article. It's not very long at all, so make sure you guys do a really good job reading. And then you guys have 2 questions to answer for this article. They are multiple choice, so use your draw tool. First question, which of the following would be true if something was at absolute zero? The molecules that make up a sample wouldn't be moving. The molecules that make up a sample would be moving very slowly, and the molecules that make up a sample would be moving very fast. Okay? If the molecules of a sample speed up, what else happens? The temperature of the sample decreases, the temperature of the sample increases, or the temperature of the sample stays the same. So what happens when molecules start moving faster? Okay, what's happening to our temperature? Okay, so answer those 2 questions. And then you guys are moving on to the wrap-up. Do you have any questions? Circle yes or no. If you guys have questions, type them here. If not, leave that blank. And then 4, 3, 2, 1, how do you guys think you did on this assignment? You could teach it. You own it. I'm still sure about a few things, and I have no clue what you're talking about. So go ahead and honestly tell me how you think you did there. And you are all done. Don't forget to hand it in, and I hope you guys are having a great day. Bye.